Did you know that 60% of cloud storage has logging disabled? You heard me right. 60% of cloud storage has logging disabled. It's these types of blind spots that we're going to talk about over the next couple minutes as we go through this presentation. My name is Matt Chiotti, and I'm the Chief Security Officer of Public Cloud at Palo Alto Networks. So when you think about a blind spot, what is it that comes to your mind? I know for me that this picture that you're looking at here on your screen, this is exactly what I think about, right? Usually it says objects in this mirror are closer than they may appear. But a blind spot is usually something that you think you know what the reality is, but in actuality, it's quite different. That is how at least I define a blind spot. And when it comes to cybersecurity and cloud security, it's when you think you understand what the cloud threat is, but in actuality, it's something quite different. So that's what we're going to talk about today over the next 30 or so minutes. Now, let's talk about some areas that I'm not going to go into detail on in this report. These are the areas of what I call cloud clarity. These are areas we've talked about so many times. I'm not going to spend any time going into these, right? Shared responsibility. I think most organizations at this point, right, cloud's been out for well over a decade. Most organizations understand that there is a shared responsibility between them as the cloud consumer and then as the cloud provider, right? They understand there's a difference there. The next area has to do with storage buckets, or should I say leaky storage buckets. This is an area that if you go back probably 18 to 24 months, this was something that was in the news probably on a weekly or a bi-weekly basis, if you remember, right? Somebody uploaded data to a storage bucket and then inadvertently it got set to public and now someone had a massive breach that they were going to need to deal with. So leaky storage buckets, that's an area of cloud clarity. The last area that I think most organizations probably understand pretty well at this point is that when they move from their traditional on-premises data center to the cloud, they have reduced visibility, right? You can't get in there and wrap your arms around that server like you used to do in the past. You just don't have that option anymore. And therefore, when you move to the cloud, there is, at least by default, a reduced level of visibility. So let's talk about the two blind spots that I think are most prevalent in the industry. And one of the advantages, one of the blessings that I have in my role is I get to speak with literally thousands of customers across the globe. And I rarely get asked about these two areas that I'm going to show you. So let's dive into identity and access management. Now, to just illustrate why cloud identity and access management is so very complex, I've created probably an overly simplified diagram, but I want you to get the point here, right? And that is, here we're just looking at a generic cloud account. The cloud provider doesn't matter, cloud provider X, right? And it's a single cloud instance or subscription, depends upon which provider you're more familiar with. In this case here, I've created two roles: DevOps admin, staging builder, and I've also created a number of policies that can be assigned to each one of those roles. Now, typically, roles are then assigned to a user. It could be a user that's right in your cloud account, or it could be a single sign-on using from a third-party IDP. Any case, this is what we're looking at here. Now, in this case, right, we're only looking at two roles and 6 policies. Those policies, they're typically defined in JSON or something like that. What they do is they allow or deny access to a service or something like that. And you can get extremely granular. There's only 3 here for each role. In most production accounts that I've seen, there's not 2 roles and just 6 policies. It's usually hundreds of roles and maybe even thousands of policies. It becomes really difficult to understand what we call net effective permissions. Net effective permissions. And all that is if you've given Jane, maybe Jane's your user, and you've given her access to both of these roles, and we're just looking at a single cloud subscription, it's really difficult to know what she can and can't do. And then that problem is further magnified when you add in the fact that most organizations, they don't have just one cloud account. They usually have multiple, right? Now we're looking at 3 accounts, and now let's say Jane has access to all 6 of these roles. And now we're not looking at 6 policies, but we're looking at 18 policies. Again, this is a very oversimplified scenario. And what I want to point out is, how would you actually know what her net effective permissions are? This is one of the challenges, and a reason that I believe cloud IAM is a blind spot for most organizations. Let's look at a red team exercise that my team at Palo Alto Networks under Unit 42 carried out earlier in 2020. And what they did was we were approached by a large SaaS provider, and they were a customer of us. And they basically said, would you red team our cloud infrastructure? Now, I will tell you that we normally do not do penetration tests. We don't normally do those. But in this case here, we were just enamored by the sheer scope and scale of their cloud environment. We're talking massively scaled, thousands of instances, hundreds of thousands of users. And the bottom line was that we were able to quickly own their environment. Now, let me tell you exactly how we did this, and maybe you can then go ahead and try to carry this out in your own environment. Number one, what we did was we brought up a completely separate cloud account. Just as if you would go out and you would get a credit card and bring up your own cloud account, we did that. And then we started to do some recon. Now, this customer, they provided us very limited information on their cloud account. We knew just a few things. We didn't have remote access. We didn't have a login username and password. And so what we did was we acted just like an attacker. We went out and we started to do reconnaissance. We searched on Google. We went to amazing places like GitHub, where developers unfortunately like to give out sometimes more information than they should. And so we were able to mine through all of that through a reconnaissance operation. Again, all publicly available information. We were able to concatenate that and then to start an enumeration exercise where we're basically testing different configurations, different role names. And after doing this process for several days, we were able to procure a temporary access token into the customer's environment. I wanted you to note here, this is one thing that I think most organizations don't realize, is that when you're carrying out that enumeration exercise, you typically have zero visibility into that. Now, if I was carrying out an enumeration exercise against your on-prem environment or your on-prem, let's maybe you're using something like Active Directory, you would see all of those failures in your audit logs, most likely. But in the cloud, when I carry out a similar enumeration exercise, you have usually zero visibility into that because I'm not actually attacking your cloud account. I'm attacking the cloud service provider's IAM service. So in the case of this customer here, they had zero visibility that we were doing this until we procured that temporary access token in their environment. And the way we were able to get that was they had a misconfigured IAM role via a role trust policy. So this was a complete misconfiguration on behalf of the cloud customer, not the cloud service provider. Now, once we had that temporary access token, we were able to see their entire fleet of EC2 instances. We could read from the metadata that was attached to those instances. And if you're familiar with metadata, there's a lot of juicy information that's in there. One thing that we noticed was that there were some S3 buckets that were meant to be readable internally by these EC2 instances only. But because of this misconfigured IAM role, we were able to read from those internal buckets only from an external account. And we noticed there was all types of information that was stored in those files. And one thing that caught our attention was a set of encrypted credentials. Now, typically, when you find an encrypted set of credentials, it's game over, right? If the encryption is done correctly, if the private key is maintained properly, it's usually game over unless you want to spend a massive amount of GPUs and processing time to attack and brute force that file. Well, it turns out we didn't have to do that. We didn't have to do it because this misconfigured IAM role, it gave us access to call the key management service, which then allowed us to decrypt and get a set of plain text credentials. Now, once we had those plain text set of credentials, we were able to log in interactively and access all types of additional services. And as you can imagine, this would have been a great way to do a supply chain style of attack, because I mentioned that we had access to their S3 buckets. Well, you can store all types of things in S3 buckets. And one of those things that we found was a source code repository. And we could have infected that potentially, which would have then impacted not only the customer, but then also all of their other customers. Now, I want to call out in this case here, right? And here's a kind of an extracted view of what we started with originally around talking about just the complexity of cloud IAM. In this case here, I've got dev, test, and prod. And while this is genericized as to protect the customer, we were able to penetrate through not just their dev environment or just the test environment, but rather through all of their environments because they actually followed a best practice. Now you're thinking, wait a second, a best practice got the customer in trouble? And the answer is yes. They used infrastructure as code templates. And because they had a misconfiguration in those infrastructure as code templates, it replicated across all of their environments, which mean that we were able to get across all of the environments and own all of those. So this is something that you need to be extremely mindful of as you build and as you mature in the cloud. Now, you might just be thinking, well, that sounds like you just found kind of like an ace in the hole, and maybe this is something that was just extremely unique to this customer. Well, we thought the same thing. Maybe they're just having a bad day. Maybe, someone just made a mistake, right? Mistakes happen. So what we wanted to do is just to see how prevalent these types of misconfigurations are out in the wild. And so we started with a massive data set, and we really wanted to look globally to understand how difficult and how widespread this problem is. And so what we did is we went out and we got a massive data set. As you can see here, we love, and you'll see this over and over again. If you look at Unit 42 Cloud Threat Research, you will see that we love GitHub, and we go back to the source over and over again. And so we essentially scraped, again, all publicly available information. We scraped almost 300,000 files and nearly 150,000 source code repositories. And then from those, right, this is essentially a huge data science operation. We were able to extract nearly 70,000 role names and nearly 33,000 potential cloud accounts, right? You can see we kind of winnowed this down, and then we had to do a little bit more refinement, right? You can't always believe just because you found 33,000 accounts that those are all valid. So we had to do a process, call the cloud service provider via an API, test if those accounts are still valid. And then, of course, we couldn't do this iteration process through with 70,000 role names. It would have just taken probably months, and we didn't have that time. So what we did is we went through and we found the 500 most common role names. And those are the ones we started with. So we basically took, here's 500 of the most common role names along with those validated cloud account list. And then we just tried different combinations, enumerating through them, looking for what are, again, some of those combinations that might cause misconfigurations. And well, let me just show you real quickly what our research revealed. Again, this is all from publicly available information, essentially a very large data sciences operation. What we found, again, with these misconfigurations is that we could have had access to literally thousands of EC2 snapshots, hundreds of S3 buckets, and a whole lot of KMS keys and RDS snapshots. Now, the level of access that we could have had to these different types of information, it varied. In fact, it varied greatly. In certain cases, it was just read-only access. And then perhaps at the worst, we could have executed Lambda functions on behalf of various different accounts worldwide. And so you can imagine in the hands of an attacker what they might do with this type of access that is so widespread and so prevalent in the industry. Here's what I want you to take away from this first blind spot. It's that when you have a compromised cloud account due to one of these types of misconfigurations, it is almost always much worse than a compromised cloud host. Now, think about it. If I am able to compromise a single host in your cloud account, maybe you're running a Windows server and it's missing a patch. I execute a vulnerability or an exploit on that. I get a shell. I can get to the data that's on that host, maybe the data that's on that segment if I find other hosts that have that vulnerability, but I'm generally limited if you've done your network segmentation correctly. Now, in the case of what we found, it didn't matter if you had every single host, every app patched, MFA turned on, it wouldn't have mattered because I could weave around all of those things when you have an identity-based misconfiguration at the cloud service provider level. So this is an area that I believe is the first blind spot that most organizations struggle with when they move to the cloud. Now, a few minutes ago, we touched a little bit on infrastructure as code. And I think that this is really an area that is really blossoming for most organizations. And for maybe some of you who are uninformed or maybe just haven't used it a whole lot, infrastructure as code is certainly the norm for most DevOps and most developer-led organizations. Now, when it comes to security teams, that is a different story. They're all over the map in terms of if they're using it and how much they're using it. But the bottom line is that infrastructure as code is a way that you no longer have to go and manually provision your cloud infrastructure. You don't have to go to the cloud service provider, log into the console, click here, click there. You can instantiate your entire cloud infrastructure in code. There are many, many benefits, but as a security team or as a security practitioner, this should be something that you are championing because it aids in standardization of a system. And as we all know, the more that you can follow a standard, the easier it is to keep that system secure. And there's many ways to do that. Now, let me share with you perhaps the negative side of it about how doing a best practice can lead to misconfigurations. What I'm sharing with you here, this is from a previous cloud threat report. If you want to see this specific report, you can just go to cloudthreat.report/spring 2020, and it will take you directly to this report where you can go into all the details. But I wanted to just share with you a couple areas that really stood out to me. The first is that, the methodology behind this specific research, we literally surveyed almost 1 million infrastructure as code templates. And again, you probably can guess where we found these. That's right, GitHub. GitHub, through the GitHub searching API, we were able to download and essentially scrape from their site all of the templates that were available publicly at the time. And what we found was that about 42% of CloudFormation templates had at least one or more insecure configuration in them. 42%. Now, CloudFormation templates, they tend to be the most prevalent simply because, and they're specific to AWS. AWS was the leader in infrastructure as code. So they tend to be what is the most out there in the wild. But 42% of the ones that we surveyed had at least one insecure configuration. Perhaps it was identity, perhaps it was something else. I'll share with you in just a couple minutes what exactly those issues were. But 42%, that's a high number. The next comes to permissive access. We found that when organizations rely upon infrastructure as code to create their external and even internal security boundaries, 76% of the time, they're exposing sensitive ports like SSH directly to the internet. That is a very poor practice, unless, of course, it's intentional. Maybe it's a bastion host or something like that. But we've seen this behavior over and over and again. So 76% allow that very sensitive access. Now, this next one is somewhat befuddling and questionable, but 60% of cloud storage, again, this is all surveyed through these infrastructure as code templates, 60% have their logging disabled. Now, this is where we started out in the presentation. But can you imagine if you're configuring your cloud account through one of these templates, that means that if you had some type of issue where you had exposed some sensitive files to the internet, if your logging's disabled, and an auditor asks you for it, or someone in law enforcement asks you for those logs, you're going to have no way to provide those. Now, one of the reasons that we suspect this number might be so high is that a lot of times these infrastructure as code templates are actually created in development environments. And then when they get migrated to those higher level environments, UAT, prod, a lot of times they're not upgraded for those higher level environments. So that's one way we suspect that this number might be so high around cloud logging. Now, the last area here that I want to call out has to do with encryption, which is very closely related to privacy and compliance. We found that 43% of the time, when organizations are configuring their cloud native databases via infrastructure as code, they actually have encryption at the database layer completely disabled. Now, if you're like most organizations, you fall under multiple different compliance mandates, from GDPR to CCPA to HIPAA to PCI. All of those have some type of encryption requirement. So these are just some of the high level findings. Let's zoom in a little bit and look at specifically what we found around CloudFormation. Okay, now CloudFormation templates, again, they're specific to AWS. And I mentioned that we found 42% of them had at least one insecure configuration. In this case here, you're looking at the top 10, but I want to call out just a few specific areas that I think are interesting. Number one, we talked a little bit about encryption already, but you can see here that when it comes to S3 buckets, which are extremely useful and extremely prevalent, that almost half of the time, 48% of the time, organizations have server-side encryption completely disabled. And this is, literally a flip of a configuration where you can turn this on. This is not, bring your own key. This is where AWS manages the encryption key on your behalf. So this is a very easy setting to turn on, but unfortunately, almost half of the time, we found it to be disabled. The other one, and maybe even perhaps more troubling, we found that AWS RDS instances, that's the relational database service, almost 42% of the time, those instances are not encrypted. So that's a challenge. Number two has to do with eventing. So when an event happens in your cloud environment, that could be a start and stop of a service, maybe a delete of a service, things like that. Well, we're seeing that almost 100% of the time, specific to the relational database service, that the event subscription is disabled. That means that if you had a security issue in your environment and related to an RDS instance, which is an extremely popular service, that you would not be able to tell forensically what actually happened leading up to a security event. So these should be on. There's very few good reasons to have these services disabled. Now, the next area has to do with logging. Logging is generally what we think about when it comes to security, but there's a separate area with eventing. So as you can see here, we found that about 55% of the time that organizations are configuring access logging via infrastructure as code templates, specifically for S3 buckets, 55% of the time, they have the logging disabled. This gives you a little bit more of a lower level view into what we're seeing. Now, I can almost read your minds here. Some of you are thinking, well, I don't use CloudFormation templates, right? I use something that's more multi-cloud friendly. Well, you're probably then using Terraform. Terraform is extremely popular because it allows you to do these multi-cloud infrastructure as code templates across all of the major cloud service providers. But those that are using Terraform, while the numbers are a little bit lower, they still had some fairly serious issues. So we found that 22% of all Terraform configuration files that we surveyed had at least one insecure configuration. Now, here's the top 10, right? You can see the numbers are a little bit different, but I think you'll see that there are some consistent inconsistencies when it comes to security misconfigurations. Number one, and I lumped all these together here, logging, eventing, and versioning. You'll see again that while the number's a little bit lower, when it comes to Terraform, we found that about 67% of the time, access logging on S3 buckets is disabled. The other one I call, and this is a little bit differently, I don't think this came up on the other one, but we found that about 52% of the time, when it comes to object versioning, that it was disabled. Now you're thinking object versioning, like why is that important? Well, it's really important in the case of ransomware. So if you have a ransomware attack and it's able to encrypt your cloud storage, if you have versioning disabled, you have no way to roll back to previous versions. You might have a backup of that file, but that backup is likely going to be encrypted itself. That's why the versioning is so important. Now, the next one, this one I kind of chalk up what I call to public exposure. And this one's a little bit scary. We're talking now about AWS RDS instances that are completely accessible to the public, right? RDS snapshot. So a snapshot, it's not a full backup, but it is a versioned backup of a smaller section of the database. In this case here, we found that, again, this is all through infrastructure as code delivered environments. We found that those snapshots, 79% of the time, are available to the public. There's all types of sensitive data that is usually kept in a relational database. This is scary. The last area is what I would call, allowed ingress traffic. In this case here, you can see there's a number of overly permissive access that is being allowed in the environments, from SSH to just security groups, which are sort of AWS's cloud native firewalls, that they're allowing all types of permissive access into the environments. So these are really two different areas that I think are really important. I think from cloud identity all the way to infrastructure as code templates, I'd say that many security teams, especially when it comes to infrastructure as code, they don't realize the threats that they might be allowing in their environment. So you're probably thinking, okay, you got my attention. I'm a little bit scared. What can I actually do to make this situation better? How do I better manage these risks? Well, there's a couple ways that I think you should look at it. And number one, that's by making sure that you have a holistic view of your cloud infrastructure and also the entire software development lifecycle. Now, we've talked about shift left, secure CI/CD for many years in the industry, but many organizations have not yet gotten to the part where they actually are integrated when it comes from people, process, and technology into all three of these high-level areas that you're looking at here. So the build phase, for most organizations, what this looks like is if you have your own developers, they might be writing a new application, maybe they're creating a new container, maybe they're creating a new infrastructure as code template. This is where you can really enable your development teams to create secure code from the beginning by enabling them with plugins, security plugins, right in their integrated development environments, so they can create secure templates and secure containers to start. You're trying to do this and trying to push security to the earliest possible point in the software development lifecycle. Now, if we move to the next phase, the deploy phase, this is really where you're looking at repositories and registries. So in the case of containers, if you're using things like Docker and Kubernetes, you might have a centralized, or maybe you have a handful of registries. This is where you can begin to scan those registries for those common misconfigurations. Again, maybe you have a developer who just created a new infrastructure as code template and they've uploaded it to a build server. Maybe you're using something like Jenkins or Circle CI. You should have the ability to be able to scan those infrastructure as code templates at the time they are checked in to make sure that there are none of those misconfigurations like we talked about previously. And then the last phase, this is the run phase. This is where most organizations typically focus their security. In fact, if I had to break it down into rough percentages, probably 80% of most security teams' resources are focused on runtime and a scant 20% on the other. Maybe it's even less. But the runtime is equally important. This is where you are leveraging cloud service provider APIs to get that visibility into your cloud infrastructure. But at the same time, when it comes to securing the actual workloads, be it a VM or a container or a serverless function, this is where you need that runtime security to make sure that a container is behaving as it's expected to behave. And then if it works outside of that, you should be able to immediately put a corrective control in place. You only get that with runtime security. So it's going to usually be a combination of some kind of agent that's running at the workload level, as well as API-based security leveraging those. That's really the only way that you can really try to address all of these and other blind spots in your environments. So in terms of maturity, this is a question that I often get asked is, where should I be aiming to go over the next few years? Well, number one, I always recommend that organizations start with deep cloud visibility. And this again goes to making sure that you are using people, process, and technology that know how to leverage the cloud service providers' APIs. You should be able to understand all of your assets across all of your cloud accounts and all of your cloud service providers in a single place. You shouldn't have to go to multiple different tools to be able to get that multi-cloud visibility. So let's start with that. That's number one. After you have some semblance of visibility and situational awareness, you then want to move to looking at how can I put automated guardrails in place? And that may sound fancy, but automated guardrail basically means I want you to think in terms of anti-patterns. What are the misconfigurations that should likely never exist in your cloud accounts? And then I want you to go out and look for those proactively. And then if you find them, to automatically take a corrective action. Don't wait for a ticket to be filed in the SOC, because sometimes that can take weeks. Look for how when you see condition X, you can take action Y immediately. The third part of this in terms of maturity is what I call code movement transparency. And this is really about mapping out your entire software development lifecycle. It could be understanding, the who, what, when, where, who does what teams, really mapping this out. I've seen many teams do this successfully, and oftentimes it takes months, but they've created Visios that really show this is the workflow starting all the way back at the developer's IDE, and this is how it moves through in a workflow. Once you've done that, that's when you can really start to understand, okay, how do I take my security tools and my security processes, and how do I embed them into that? That then leads us to the fourth step, which is about setting quality standards. And quality standards is just another way of saying that security becomes another component of quality. And so this is where you set your security standards. And security standards are really important. They're always important, but especially in the cloud, because you cannot automate what you haven't standardized upon. This is where you should be looking to heavily leverage infrastructure as code templates. Now, the fifth step, this is where what I call you're at cloud optimized security. This is where you've got security, people, process, and technology fully embedded into your CI/CD pipeline. You're looking at all things in terms of cost controls, compliance, security. You're leveraging things like cloud DLP. You have strong IAM governance, and you're doing that across all workload form factors. Don't just focus on traditional VMs because you're using those today, because I can tell you that in your future, no matter the industry, containers will be in your future, even if they're not there today. And then even further out, and again, this is still a little bit further out, organizations, many of them I've worked with, are starting to experiment and leverage serverless functions. So make sure that you've got that full visibility across all of those workloads. Now, how do you apply some of these things? Well, I tried to stay away from the 30, 60, 90, simply because depending upon the size of your organization, if you're in a 500 person organization or a 300,000 person organization, the timing is going to be wildly divergent. So these are the kind of the three next steps I would encourage you to take. Number one is make sure that you are gaining and maintaining that multi-cloud visibility with threat detection. This is important. If you remember the pyramid on the previous slide, this is that first step. You always want to start there because it becomes really critical and almost impossible to do the rest without visibility. So that's number one. And you can typically get that capability from a cloud native security platform. I encourage you to start there and then move up. The second piece, and this goes directly to the IAM security pieces that we talked about earlier in the presentation, I want you to go out and look at how you can auto-remediate some of those really common excessive IAM privileges and misconfigurations. As part of our previous report, we actually developed an open source tool, free to use, called IAM Finder. You can either go to the link or you can just go to GitHub and search all one word, IAM Finder, and you can run that against your AWS environments. The next piece, and this is easy to say, but difficult to do, but to make sure that you have a program in place that will allow you to shift security left. And there's really kind of two high-level pieces to this that I want to call out. The first is I want to make sure that you are scanning all of your infrastructure as code templates, containers, etc., functions, whatever it might be, prior to deployment. I want to make sure you're doing that. And then I want you to also be willing to not just report on issues, and they might end up Jira, some kind of bug tracking, but if you find something that's critical or high severity, be willing and have a process in place where you will actually break the build. Don't push misconfigurations to production or UAT environments. Well, I hope you enjoyed a lot of what we talked about today. And I would encourage you to download our latest cloud threat report, where we spent a lot of time looking at security pre and post COVID-19 discovery. You can see that report by going to cloudthreat.report/1H21. Thank you so much. I hope you enjoyed the talk today.